Welcome to the channel where all you gotta do is test this Bell intercooler core. Okay, a little bit Flowbench fun today. So I put some yarn tufts on this thing and I built a little box, which I'll show you a little later. But you can see from the tufts, and there's a hole in the center here, you know, yay big. Definitely more air is getting through the center here, but it doesn't look terrible. It only takes about 4 inches of water to equalize it. So when this thing's flowing, you know, hundreds of CFM, that should be no problem. I got some flow numbers here, so I'm gonna poke it into my spreadsheet and see what the restriction to this thing is. So I can convert it to, you know, the CFM that the engine's going to use and see what the delta P is going to be across this thing. Now that isn't exactly right, because if this thing's doing its job, it's cooling the air temperature, and that will inherently, just lowering the temperature of the air charge will lower the boost, even if there was zero restriction through here. So it's kind of a, that's why computational fluid dynamics is a thing, right? Because there's multiple things happening. At least 2, but probably 15. Right, there's major head loss, there's minor head loss, there's conduction happening different rates from the temperature on this side, temperature on this side. Like, there's lots of things happening. Cooling the charge isn't cooled evenly, you know, interfaces with the walls, boundary layers, like tons of stuff's happening. And that's what a computational fluid dynamics program does. That's why you can't just like put a spreadsheet in, figure out what your boost is going to be. It's very complicated. There are fudge factors. If you open up a heat transfer book, it's about 97% fudge factors. Like, people ran experiments in the 30s and 40s and 50s and figured out dimensionless parameters that you can use, the Prandtl number and the Reynolds number and yada yada yada. I'm not going to go into that because it bores the hell out of me. And one thing I learned in heat transfer class was it's all wrong until you test it in your exact configuration. Like, you can get close using the fancy numbers and equations and dimensionless parameters, but until you test what you got, you don't have any confidence, really, at least. My opinion is a skilled engineer can guess closer than you can get with the numbers. My opinion, I could be wrong. But anyway, let me show you what's inside this box. I just got some modeling clay here, which is typically what I use to seal things up. Set that over there. And this is super crude, right? I get giant gaps in there, but just some scrap metal I had, or scrap not metal I had laying around. So that's it. And this is approximately the height of my intake manifold diffusion area. So I'm probably gonna lump some thicker clay on here and raise it up and see if it makes anything better. Typically these would be on an angle as well, right? This surface would be on an angle, which I can totally replicate with just gluing a piece of stick in there. So this is just to test and see how effective that core is going to be for me, what kind of pressure loss I'm going to see with it, and whether it's utilizing the entire core. I still go by my original statement, and this fin density is a little bit too coarse. I'd rather have more fins per inch, I think, but until I get the data into the into my spreadsheet, again, it's just one piece of the losses, right? This is just the losses through this core. It has nothing to do with heat transfer. It has nothing to do with, you know, all the other stuff I said that CFD does. I'm not going to do CFD though, because I don't have fancy spreadsheet for that, but or a fancy program for that, which costs a lot of money. Anyway, that's quick and dirty, and this stuff isn't only available to, you know, fancy pants shops. Like this Flowbench I built. There's a YouTube video on it. I don't remember exactly how much it cost, but it was under $400 or $500, something like that. Just a couple of sheets of MDF and an old power supply I had laying around, 4 leaf blowers that I got used off eBay for, you know, anywhere from 35 to 60 bucks each, and then a pressure transducer used for HVAC, and this fluke meter that was already in my toolbox, so I didn't even have to buy that. So I think there's a mass air meter in there too, which is another 25 bucks or something. But anyway, you could put one of these together. It's within most people's means. If you have a shop, if you have a car that you want to make go fast, this is totally within your means. And if you got a skill saw and a little bit of skills, you can make it. Anyway, poke a like down there, up there, wherever yours is, and see you in the next one.